So, monomial, one term, binomial, two terms, connected by a plus or minus. Trinomial is three. Polynomial is a big, all-encompassing term that it could mean any of these. This is a polynomial, this is a polynomial, this is a polynomial. Sometimes we get more specific when we want to for some reason, like we might want to say, find the binomial that, and when they do that, they're trying to give you a clue. It's going to have two terms. Or which trinomial, so it's a clue about how many terms it has, but the word polynomial is a general term that can be any of these. And if it has more than three, we stop being specific at that point. We just call it a polynomial. So the pieces of a polynomial, we should talk about just so we've heard these vocabulary words before. It's a lot of vocabulary in here. Most of this is not new. So this part is a variable. Did we know that word? Yeah. That's a variable. That's a constant. I mean, it's a number, but it's a constant because it doesn't change. So constant, a variable, a monomial, when we combine them all together like this. What is this thing? It's an exponent. A little bit worried. Okay, when the number's in the front like this is a good one to definitely know. When the number's in the front like that, this thing is called a coefficient. This is not because it stands alone. It's just a constant. But we use the word coefficient to talk about the number that's paired with these. It means there's two x squared y's. It's telling us how many of them there are. So when it's paired with the numbers, this is a coefficient. Here's a coefficient, here's a coefficient, 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 meaning that they're sharing. So they're together. We can put these, and we don't do this very often because most of the time we don't care, but we can put them in order, and the traditional order is descending. So here's a polynomial. How many terms does this polynomial have? Do you see the 4 terms? So that's 4 terms. We've put those terms in descending order because we put the powers going down. That's the way we usually do it, but it is possible to do an ascending order, which means going up, and we would write -8 plus 6x. That's not how we usually do it. If we wanted it in ascending order, we would do it like that. But this is the traditional way to do it. When we do it like this number is called the leading coefficient. How much does that matter? Not a lot, but it is a term that math teachers such as me will throw around. So it helps if you're familiar with it. So when I say, okay, look at your leading coefficient. This is the one in the front, the one in the lead, when it's put in order. So even like this is the leading coefficient because it's the one on the biggest term. And the reason it matters is because that number is going to dominate the graph. Because the x to the third term is so much bigger than the other ones, it's going to have a huge influence over the whole graph. And the shape of the graph is determined completely by that biggest term. So anything whose biggest term is an x to the third has this vague shape. And it doesn't matter whether there's an x squared in it or not. You could drop all of that off and the shape of the graph won't change very much. A little, but not a lot, because this dominates the picture so much. So a leading coefficient is the one in the front when we put it in order. You won't have to know that or write it or put it on a matching test, but I will say things like, what's the leading coefficient? And I would like you to know the answer. So most of this section is vocabulary. There's some problems on when we plug numbers in, which we just practiced on that cumulative review, right? Just plugging the numbers in. That part's not hard. And there's combining like terms. Again, the book says collect like terms. I don't feel like that adequately gets it. I don't want a collection of them. I want to literally put them together. So, let's play another round of Are They Like Terms? Are they like terms? Yes. Can you combine them? Yes. Let's do this. Can you combine them?
Yes.
Yay. How about these two? Are they like terms?
No.
No. Could we combine them?
No.
No. If we try to put a plus here, they remain a binomial. We can't put them together. This is the answer if they ask us to add them. This is addy as they can get. Okay, how about 7x squared and 7x? No. Which part has to match? All the variables and all their exponents to be like terms. So 7x squared y to the third and 7x squared y to the second are not like terms. But x squared y to the third and x squared y to the third, let's put an 8 in front of that one. The big number, the coefficient, doesn't matter. That just tells us how many there are. So I have 1 x squared y to the third and 8 x squared y to the thirds, which gives me a total of 9x squared y to the thirds. So what has to match is all the variables and all their exponents down to the very last nitpicky detail. X to the negative second and x to the second are not like terms. You cannot add them. Every detail of the variables and exponents has to match if you're going to combine them. So this section is 1 to 25. How far are you already, Wendy? How far have you made it?
14.
I was really thinking it's Friday and we should just make it odds. I kind of want to. It gives you a lot of extra work, but it just still saves you some. So we're going to make it odds because it's Friday.
And I would think it's a 3 for the second one.
208, 1 to 25. Odd.